Okay, guys, this video we want to talk about some word problems that deal with the Pythagorean theorem and its converse. So to kind of recap what's going on with the Pythagorean theorem, if you have a right triangle, then it's true that a squared and b squared is equal to c squared, where c is the longest side opposite the right angle, the hypotenuse. So a squared and b squared is equal to c squared for a right triangle. Now, you can do more with the Pythagorean theorem than just test to see if you have a right triangle. And I know you've probably done problems where, let me put a square there, you're given like a hypotenuse and a side, and then you got to see what the missing side is to make a right triangle and so on. Or you got the two sides, see what the hypotenuse is. You can do more. With the converse of the Pythagorean theorem, you can actually test and see what kind of a triangle you have. And it turns out that if a squared and b squared is less than c squared, and the way that you pick these is the big number always goes in for the c, the other numbers for the side lengths go in for the a's and the b's. It doesn't matter which one. But if the pattern is that the sum of the shorter sides squared adds up to less than the hypotenuse squared, you have a triangle that has an obtuse angle. It's not right, but it's obtuse. So it kind of goes opposite. If these add up to less than c squared, an angle is bigger than a 90-degree angle. And then if a squared and b squared comes out greater than c squared, then all your angles are less than 90 degrees and you have an acute triangle. So not only can you tell if you have a right triangle, you can also tell what kind of a triangle you have with the converse of the Pythagorean theorem. So Pythagorean theorem converse. So what I wanted to do with this video, there's another video that talks about Pythagorean theorem and the converse also, along with Pythagorean triples. What I want to do is do some of these word problems that deal with the Pythagorean triples. Let me zoom in a little bit on this. Let's see what we got here. So a square has side length 10 yards. What is the length of a diagonal of the square expressed in simplest radical form? What we always want to do on these word problems is draw a diagram to represent the information. So for number 13, they're telling us that we have a square. It doesn't have to be to scale. And each side length is 10 yards. Or you can mark them as all being congruent to each other. What is the length of the diagonal of the square and expressed in simplest radical form? So here's the diagonal of the square. If it's a square, it's made up of right angles with opposite sides congruent. And to find the diagonal of the square, we want to apply the Pythagorean theorem. A squared plus b squared is equal to c squared. So 10 squared plus 10 squared is equal to c squared. 100 plus 100 equals c squared. 200 equals c squared. And we want to take the square root of both sides. So c is going to be the square root of 200. Okay, so to continue on here, let's look at this next problem. So we talked about the wall problem. When field archaeologists plan an excavation or digging site, they place a rectangular grid over the surface. So then they take photos and measurements how far down and stuff for future research. An archaeologist decides that the dimensions of such a grid would be 11 by 15 meters. She would place stakes at the corners of the grid. How can she make sure she places the stakes in the correct location? Explain. Okay, so let's kind of diagram this out. So we've got 11 meters by 15 meters. So I would think that she could place like one stake and then 11 meters down place another stake. So what she could do is, like with a piece of rope that's measured at 11 meters long, she can probably do like a arc, like a compass type arc thing with it, and swing it around and kind of temporarily place the stake there. For the 15-meter one off here to the side, she can just over here just measure 15 meters out and just place the stake. So she's going to place this one at 15 meters. She's going to, this arc here represents all the points that are 11 meters away here, and this stake's just kind of here temporarily. Now this is where the Pythagorean theorem comes in. 15 squared and 11 squared is going to be the length of this diagonal when you take the square root. And I did that, let's see, in the calculator, and let's see what we get. 15 squared and 11 squared. $15 squared and 11 squared comes out to be 346. And if we take the square root of that, we get 18.6. So 18.6 meters. Now, 0.6 meters works really well. 0.6 with meters, that's like 18 meters and 6 centimeters. And what she could do then is take another piece of rope, or remeasure the rope, and to 18.6 meters, and from this stake here, which is 15 meters aside, swing another arc. And this would represent all the points that are 18.6 meters away from this one. Where those two arcs meet, that would be the place to place that stake. And then she could basically do the same process on this other side. She could kind of do the 18-meter thing here, swing an arc, and then measure down here 11 meters and swing another arc, and would have a rectangle set up with 15 by 8 sides. Because if the diagonals are 18.6 with 15 and 11, that means that this is a right angle there. And if you do the same thing on the other side, you got a right angle there. And that's enough for this whole area then to be a rectangular area. So swing an arc 11, kind of place the stake temporarily. Measure over 15 to the side. Swing another arc of 18.6, which is the diagonal. And where those two meet is where the first stake should be. And then basically repeat the process for the other corner. Okay, let's look at number 17. Now there may be another way to do this, but that's just the way I came up with. A river runs straight through the center of a park. A man stands on one bank and his daughter stands across the river and 22 feet upstream. So we got to diagram this out. So the river runs through the park. A man is standing on one bank. His daughter stands across the river and 22 feet upstream. So his daughter is over here, and they're telling us that this is 22 feet upstream from here to here. The man's son swims from the man to his daughter. So the son is going to swim like that. If the river is 11 feet wide, how far does the son swim? So what we have here is a right triangle with an 11 side and a 22 side, and a squared plus b squared equals c squared will let us find the length that the son swims. So we're going to do 11 squared plus 22 squared and take the square root of that, and it says round to the nearest foot, and then that will give us the distance the guy swims. So 11 squared plus 22 squared equals 605. Take the square root of that, and we have 24.59. Now 0.59 is a little bit over half of a foot, so we're going to round to 25 because we want the nearest foot. So I'm going to write like 24.6 and then approximately 25 feet. So this distance here is about 25 feet. Okay, so that's it for these word problems that involve mainly the Pythagorean theorem. These up here were examples that involve the Pythagorean theorem converse.